All right. So you guys just got done taking your test, and I want to focus on, let's see here, finding the area under a curve using the limit process. You guys know what I'm talking about with that?
Is it the one where you do the derivative and you use the points?
Nope, no derivatives. This is where you have to do it manually. Does anybody remember what that formula is? I'll give you a hint. It involves a limit and it involves a summation symbol.
Oh.
Yeah.
So the area
it's
would
delta
be
x.
okay.
Like that.
So
I.
The area, if I can spell area right, is a limit as n goes to infinity of summation
I equals whatever the number
1 to n
X dx. Oh,
F of CI delta x.
Oh, I was so wrong.
Okay, do you guys remember that? We talked about it last year.
I tried to avoid that. So
Okay, well, I don't want you to avoid it because we're going to have a quiz in the not the near future, but not next week, but the week after that, where you're going to have to do one of these. Okay. And I'm just telling you now, it'll only be one, just like I think last year I only gave you one, but it's just to make sure that you guys understand what's going on. Let's talk about this a little bit. So let's say that we've got this curve. Let's say that's x and that's y, and our curve does whatever it does, and we are interested at going from, let's say, A to B, and we want to find this area here. Now, you guys already know the fundamental theorem of calculus, but let's say you didn't know that. Well, we can actually use what we call Riemann sums or Riemann rectangles to get that answer. So what I could do is I could draw like 4 rectangles under that curve, right? And I can find the area of those rectangles and add the 4 of them together, and that'd give me an approximate answer, correct? How could I make that more accurate? Trapezoids makes it more accurate. What's another thing I could do? Let's say I stick with rectangles though. More rectangles. So if I did 8 rectangles, that'd probably be better still, right? Mm-hmm. If I did 16, that'd be even better. In fact, if I did infinitely many of them, that's when I get the exact area that I want. Okay, so to point a couple of things out here, what does this here represent in terms of our rectangles? F of C sub I. Close. The width is this part right here. This is the change in x, right? This is how much x is changing by. So that's going to be the width.
Is it the middle point?
Nope. It's the height. Right? So think about it. Delta x is the change in x. So that's how much the x is changing by. So that's how wide it is, if you will, the width. When you plug some value into the function, that gives you the height of the function, right? So this is going to give us the width of the rectangle. That's going to give us the height. And by the way, what we're going to do with all those areas, we're going to add them up. That's why it's called a Riemann sum. We're going to add them up. And how many are we going to do? Infinitely many of them.
Until you hit 6 feet under.
Correct. Now, let's talk about a couple of other things that are involved with this. Let's do purple. Does anybody recall what the formula is for delta x?
Oh.
Slope. Now it's not.
Now I feel stupid.
B minus A over N. Now, guys, this is from last year, but this is, I think there's some stuff like this on the homework too. Okay. So if you don't have that one, I'm assuming you're not going to get this one. Does anyone want to take a stab on this one?
It's B over.
This one is A plus B minus A over N I. Now I'm giving you the formula. Last year I didn't give you the formula. In fact, last year when I did this, I always said that we're going to start at 0, a 0, right? I'm telling you this year it may not start at 0. Like in this case here, we could say maybe A is at 1 and then B is at, I don't know, 3 or something like that. Okay, so What would delta x be in this little example I drew? 2 over n. 2 over n. What would c sub I be? 1 plus 2 over n I. Does that make sense? Okay, so what I want to do is I just want you guys to practice one problem. We're just going to practice one problem and then we'll play some 24. Okay, and let me make sure I tell you the problem I want you to do. Okay. This one I'm going to make it start at 0. Okay, so this is a different problem. So here's our practice problem. So I want you to find the area under the curve 1/2 x squared plus 3 from 0 to 2. Oh, actually, you know what? I guess there's some other things I need to remind you of. Do you guys happen to remember the formula for the sum of I to 1 to n of I?
No.
Oh wait, it's the integral? Oh no.
Coming back slowly.
Okay. Do you guys happen to know? I'm going to give you one more. I'm not going to tell you the easiest one, which is when this is a constant. I'm going to let you figure that one out. And by the way, if you can't figure it out, you're more than welcome to look it up online or in your book or whatever. Okay. Does anybody remember what this one is? Do you remember that one?
No, I don't remember any
Yeah,
of it.
okay. So let me point it out. Let me tell you which page it is in the book. So I'm not going to tell you the last one. I'm going to force you to either look it up. And by the way, you could just Google search this. But just to remind you in the book, I think it's section 4.3, but let me not be a liar. It might be section 4.2.
And it's the.
Yeah, it's section 4.2 on page 2. Just remember section 4.2. You can look it up. Just look up the summation formulas. You can Google it. Anyways, there's the two. Like this is the one that I definitely would have had you do last year. This would be the worst case scenario I would have asked you last year and this year. I'm not going to ask you to do anything beyond that. The one that I've left off is this guy right here. And I'll just call it C for a constant. Okay. I'm not going to give you everything. Okay, so you have to do a little bit. All I want you to do is I want you to try to do this problem. By the way, you guys already know FTC. You could figure out this answer or use your calculator to figure out the answer. I want to see if you can go through this whole process. Do you think you can try? And then I'll help you if you need it, okay? I'm going to pause the video now. Okay.
Whoever watches that video